Hi, Andrew and TA teams. So today I want to introduce our research topic, which is deep learning-based surrogate model for subsurface flow problem. So for this project, we introduced the surrogate model. So why do we do that? The main reason is that sometimes when we need to do optimization problems for well placement, it's very expensive. We need to perform a lot of reservoir simulations. So with a CNN-LSTM based model, we can accurately predict production rate and only use a tiny fraction of time compared with previously what we need to do. So how do we achieve this goal? First of all, we need a model. So this model is a recurrent residual UNet. We know that UNet is super powerful when we need to deal with graph-based regression problems. In this model, we use CNN for both encoding and decoding, and LSTM for time series. So as an input, we input two channels. First one is the permeability field, which basically tells you how permeable or how the fluid can flow. And the second channel is the mask of well location. Since we only put 0 to all non-well grid blocks and 1 or -1 for producer and injectors, which are two different kinds of wells, the matrix is pretty sparse. To make the model more aware of the well location, we introduce a 3x3 mask to stress these points. In order to train our model, we also need a loss function. So for this problem, we basically use a loss function which will reduce the difference between the training set and our prediction of the saturation and pressure matrix, which are the output of our decoding net. As we can see from the learning curve, that our model converged pretty fast. Around 1,000 epoch is already pretty small of the loss. Let's see the figure 3 and figure 4, which are the direct output of our model. The upper part is the test data, and the lower part is our prediction from neural net. We can see it's very hard to tell the difference from the up to the downside. So with those data of pressure and saturation, then we can calculate the oil rate from the production, which is also the quantity of interest by ourselves. So we can see here the prediction from our neural network pretty good, represent the result of the test pretty well. In conclusion, our surrogate model can be a very useful tool when we need to deal with many simulations, such as the optimization problem. In the future, we will consider to put more stress on the near well data in our loss function so that we will be able to reconstruct the rate even more accurately, since the rate is computed with mostly the near well saturation and pressure data. Thank you so much.